On? Great. So yeah, my name is Dimitri, and I'm a data scientist at OncoHealth. And today I'll present you this one use case, specifically focusing for executive users, allowing them access to the latest and complete patient data that we have. So let's begin. The outline for my presentation is we first go over the motivation for this use case, our approach in building this, leveraging Databricks and as well as Elasticsearch, and finally the application for executive dashboards in Kibana. So our motivation is, as aforementioned, we want to see and understand, have a view into the comprehensive patient data that we have. So first, by a show of hands, how many of you are familiar with healthcare data or work in healthcare? Okay, so almost everyone. How many are familiar with oncology? Okay, so a lot of people as well. Great. So then you know this. Oncology is one of the most complex and fast-moving therapeutic areas, especially over the past few years with the variety of genetic targeted therapies coming to market. We have a variety of new tests, genetic markers, and a variety of treatment considerations that are being developed, really introduced sometimes at conferences to oncologists. And the goal is to balance efficacy and toxicity. And the treatment considerations for each oncology patients can be quite complex. And however, cancer treatment review, understanding how patient is really responding to treatment and incorporating this information in treatment development really requires the latest information, requires today's data. And structured data sets like EMR, kind of the metadata for a patient being treated by a physician and interacting with the healthcare system, the schema for these things is slow to change. And they're not going to incorporate the genetic markers and variety of tests that are required to really understand how this patient is performing on the latest therapies. And advanced and most important clinical information these days for considerations for complex cancer therapy considerations is locked away essentially in unstructured clinical notes. So these are the notes, documentation of the patient within the healthcare system. At OncoHealth, our core business, the company was built the past 15 years, providing independent cancer treatment review. And the big advantage that we have is deriving insights and having data at the medical moment of truth. So our board-certified oncologists, which are up to date on the latest literature and considerations, guidelines, case and trends, and FDA approvals, they approve and drive new treatment considerations for each complex cancer treatment case. And so they want to drive new treatment considerations as new clinical evidence becomes available. And our advantage, once again, is that for every single case, every single treatment review, we have the complete, by definition must have, the complete patient data in order to make that decision. So as new genetic therapy becomes available and this patient, as advanced patient, complex patient is being considered for it, we must have complete testing results, imaging, lab results, whatever is required for that patient is included in the communication between our oncologist and the treating oncologists. And our goal currently as the company has become a digital platform for oncology in general. We want to discover and capture these emerging clinical insights and emerging clinical considerations within unstructured text into a structured life sciences data set. And so as at the latest conference, there's been a new clinical evidence that came out about a particular genetic treatment that says a certain exon deletion has become really important for patient response. And our oncologists, we see this immediately within our data as oncologists are submitting this supporting data for the treatment choice. And this particular genetic factor has become important, and we want to have a quick pipeline in order to take that information, important clinical consideration, and capture it in a structured way. So at OncoHealth, however, we are dealing with an onslaught of clinical text, and some of you may be familiar with this. So over the past 15 years of this company doing independent clinical review of treatments, we've collected millions of documents, and at times, as patient documents are pouring in on a daily basis, we're receiving at times tens of thousands of documents or tens of thousands of pages of documents for a single patient. And traditionally, an oncologist would sit down, they would print out, maybe 10, 15 years ago, they would even print out this information, they will highlight it and write a detailed review as to why a patient should receive this treatment, even though, of course, balancing the toxicity they would have to this patient and why this is the right recommendation, and then have a discourse with another oncologist. And however, now, we have really, truly tremendous number of PDFs. And as long as this information, of course, is hidden, stays within these PDFs, it might as well be locked away because it requires a human being to look through it and identify the important content within. And our goal now at OncoHealth is truly to unlock this text information. So as we want to extract the emerging clinical evidence that's required for treatment, we want to ask for each particular treatment in question for which we want to unlock this information. We want to ask what is the what is the patient cohort size? How many patients we have for this particular clinical consideration? What information is available within their documents? And we want to understand this, of course, at scale in order to extract these facts. As I just mentioned, we have a tremendous number of these clinical notes that are coming in for each patient that have the complete information required, including the emerging clinical considerations that are required for complex cancer treatment. And this can include treatment orders, progress notes, imaging reports such as X-rays, MRIs, actual scans of those, as well as documentation of other physicians that are reviewing them, lab reports, and pathology analyses. In addition to this, in order to support these treatment considerations, our oncologists also receive medical claims, they receive electronic health records, and during case submission, we require providers to submit additional clinical facts that can assist in this process. And so together, the comprehensive patient view at OncoHealth includes unstructured clinical notes, a large volume of them per patient, as well as a variety of databases, as we mentioned here, from claims to electronic health records and case review. As long as we have this most important information in clinical notes locked away in PDFs somewhere in our cloud storage, it might as well be this card catalog, right, where we have a black box directory of millions of documents and associate data, structured data in databases on this patient. And our goal is to go from that to a unified single source for accessing truly all of the patient data, including all the associated text, as well as all their structured data that is up to date. And in order to do this, we leverage Elasticsearch and its integrated API in Databricks in order to process all this data and set this up. And so next, I will review our approach briefly, as well as show you some of the one particular use case for it. This next steps will not be too technical, but they will review specific steps in the process we had to take to make this solution for comprehensive patient data view work. So the first step is structured data processing. And this is where Databricks plays a huge help for us in that we use built-in API to connect to a variety of data sources. And for structured data sources, most commonly it's SQL databases that are for EHR, claims, and case review. And we make these connections within Databricks, as well as connect to our cloud storage, which is in Azure, to access documents or any additional Parquet files that are required. And then the next step is really important, is a separate process altogether, is to identify a unique patient across all of these data sources. And again, our clinicians within OncoHealth, we're allowed to see PHI data, and so we have our own algorithm to go through all of these databases and identify a unique patient and map them across the different data sources. Next, of course, is the clinical facts like diagnosis, protocols, procedure names. Although they tend to be standardized per a particular data source, they're not going to be standardized across them. And it's really important for us, again, additional processing step in our pipeline in order to standardize all the critical components of our structured data into a single unified format. And finally, we have per patient data aggregation. We're truly interested in viewing for a single patient, whenever we search for that patient, a comprehensive view, the claims that they had, and any structured data we have collected on them, we want to see them associated for that patient. And here again, we leverage the Spark NoSQL data representation, which allows for a nested structure of all the variety of data sources for that single patient ID. And we collect this data in Spark data frames that are then put into Databricks Delta tables, and we leverage distributed aggregation processing because it becomes really heavy processing, for hundreds of thousands of patients, a variety of data sources. And as we continue to run these updates for up-to-date tracking of all our patients for structured data, the tracking with Delta tables also gives us huge help for understanding the metadata statistics on how much data we're processing on a daily basis. Once we've completed the structured data processing, the next step is that merging all those data sets is quite complex. However, as far as data volume processing, it's still on the low end. The most difficult, heavy processing task is dealing with all the text data. And here, for each batch of patients, we once again leverage Databricks Delta tables and Azure API built in the Databricks notebook to read all associated documents for that patient into memory and put them into the Delta table. Then we perform an aggregation, if you join that to the aggregated patient data that we just went through that process. And then once we have this complete data entry, which is shown to you here, for structured data entry, we have the patient ID and all associated data in a nested format for that particular patient. Next, we create here at step number 2, all the text data, and again, put into a JSON format in a single row in a Spark data frame that is then, or equivalently in the Delta table. And finally, these things are merged together in a single Delta table that can contain the nested structure for the complete patient data. So all the associated facts for that patient, as well as all the text. And we segment all the document text for one page at a time. And so this is the final data entry that we want to send to Elasticsearch in order to index all of that data. And so index, process all that data within Elasticsearch, which we'll discuss next, and to be able to view it and search it very quickly. And so we configure an Elasticsearch client connection to the Elasticsearch client in Databricks, and then stream this data from Databricks to Elasticsearch. Ultimately, this data is being streamed from a cloud storage, leveraging Databricks processes, to an entire different cluster for processing, which is Elasticsearch. So I've mentioned Elasticsearch a few times, and some of you may be familiar with Elasticsearch already, but why do we leverage Elasticsearch, and what does it do? So Elasticsearch provides for us scalable index-based searching and ranking. Essentially, this is the technology based on which Google operates, so Google search, right? Allowing you to search truly billions of pages, immediately or within seconds and get your results back. So this particularly, it's most important for searching text, so it allows us very quickly to search terms, flexible phrases, and has additional algorithms built in for relevancy and get the most relevant data back across millions of records. And together with unstructured data, we can search structured data, we can search for exact values, and apply filters similar to SQL, and search for ranges and dates. And then there's more additional complex algorithms that allow for, across the combined data, do proximity matching, and as well as built-in aggregation pipelines to get additional insights, leveraging Elasticsearch computations. So if you're not familiar at all, again, this is the technology that transformed the search space. And the basic idea why this is much more powerful than reading data as you do Control F maybe and searching for a particular term, or when you do SQL and you do a like statement and you read through all the data and find the particular text you're looking for, is that in indexing-based search, we move the heavy processing for understanding that text up front. And so this data is read through once during the ingestion process when we send all our millions of records. Initially, this data is being processed to create a lookup table for all these documents, for the text that these documents contain. And then, instead of when we search for a word, like let's say an example here, we have 3 documents, and we don't have to read all these documents into memory. Once we have this existing index with all our documents within them, when we look for the word universe, we do not need to bring every single word into memory and identify where the word universe is located. We go directly to the lookup table, which is the index, and find exactly where that document is located and serve you that document immediately. And when you apply this technology at scale, it's truly transformative, and allowing you to have insight into your documents. When you're working with millions of documents, it's something like thousands of times faster. For pushing this data from Databricks into Elasticsearch, we leverage both the Python API and the Spark API. The Spark API, of course, is really important for speed. For our processes, it tends to be 7 to 10 times faster. And once we aggregate all that data into delta tables, well partitioned in a Z order, we send them to Elasticsearch through this particular API. And of course, streaming optimization within Databricks allows it to happen much faster using distributed resources. However, for particular data updates, as data changes for a specific patient, we want to update it just a number of elements within the data or a particular set of rows or target a specific patient and update that data, we find that using the Python API can be quite useful for that specificity. All right, so next, I will briefly review a specific use case, which is Kibana dashboards that allow executive users at OncoHealth, which are not allowed to see PHI data. But as we create these, as we capture these emerging clinical insights, which are really important for these novel treatments that are coming out, we want to be able, our executive users, to form research innovation partnerships with healthcare providers and drug developers that want to see this data and understand and mine this data and then leverage it to improve drug development. And however, again, our executive users are not allowed to, of course, show and not allowed to see PHI data. But we want to understand what information, what latest clinical considerations are within our millions of records. How big is that cohort? What information is in there? And we want to be able to mine this. Of course, in addition to this, we do have a separate tool that is specifically for our clinicians, allowing them to search all our data. However, I'm not able to show this here because that is protected data that has to go through a very long list of approvals before being able to ever show, or we are not allowed to show it altogether. And so today I'll specifically showcase this use case of dashboards for users who are not allowed to see PHI, but want to understand what's within our data. And so here's shown one quick kind of overview, and this is a sample index that's been built on our data. As you can see, this index has over close to 1.5 million documents, and right away, an executive user without seeing any particular, without seeing PHI, of course, they're able to get some basic volumetrics and answer the question: what is the total population of patients that we have, and what kind of data do we have on them? And of course, this can be further customized, and we'll go through some more examples. And so here, as you can see up top, we have a search field where they can search all of this text, just the way you would search Google, and identify, search for particular terms that are of interest for an emerging clinical evidence. And we have a date filter for all the documents. We have a filter for diagnoses and protocols, which are the treatments that are assigned to a single patient. So first, within this dashboard, now that we have a comprehensive data of the patient mapped within, we can quickly select, an executive user can select the criteria. In that case, we're interested in the patients who have a diagnosis for bladder cancer and breast cancer. We want to know what that cohort size is, how much data do we have for this patient in terms of documents, as well as all other associated structured data. And right away, we can get those statistics immediately. And so here, as you can see, we apply search criteria for 2 diagnoses, and we get statistics on what data do we have for that patient immediately. And really, the power of this tool is shown here. So now, we have applied structure criteria to this data, and data has been filtered, and we know what the broader cohort was for the patients who have these 2 diagnoses. But next, we're interested for patients who have both of these diagnoses, and this is truly a sample example that we're interested for these patients. We want to search through all of their documents, all their associated documents right away, and see for which of them there's a discussion of adjuvant therapy being applied. And as you can imagine, we can filter for a particular protocol as well, or include other discussions that we would like. And so we want to search all these documents. In this case, it was about 10,000 documents prior for all these patients, and identify which documents have a mention of adjuvant therapy, because it's an important concept that we now want to capture. And so right away, an executive user can answer that question and say, look, we've searched through millions of documents for our patients and all their data. We identified this cohort, and we know that we have more than 2,000 documents, which we can mine, and a cohort of patients, a cohort of 585 patients for whom we have this information that we can capture and study. Further on, we can build more advanced aggregations in Elasticsearch and drive additional visualizations that are useful for executive users to understand, again, what is inside our data. So one of the important things for medical documents, of course, is for a term like adjuvant therapy or any other clinical considerations is what kind of document is it found in. The typical medical record, the most common labels for medical records are things like progress notes, lab reports, pathology reports, chemo orders. And you can see here, when we search for adjuvant therapy, most of these mentions are available within progress notes. And so we have, in this case, 90 patients that are receiving treatment for neutropenia or receiving neutropenia treatment, and they're associated, so we have their treatment protocol, and we have adjuvant therapy found within the progress notes. And we can build a variety of different aggregations, again, to serve this insight, and most importantly, is immediate, right? So we can go ahead and filter, apply structure criteria, and apply text search criteria, and to get insights immediately into what is available within our documents. So further on, just giving you more examples of data aggregations that we can build in as we have users come back and say, look, when we search these criteria, we want to be able to talk about other clinical factors that are important to us. One of those, of course, is line of therapy, patient tenure, as well as genetic markers, where there's a variety of genetic markers that we now mine and capture within this data. And so we can know for our patients that have this neoadjuvant therapy, they're receiving, they have diagnosis for bladder cancer and breast cancer, we can see that the certain genetic markers that they have, patient tenure and line of therapy, we can understand the distribution of these important clinical factors for these patients right away. So a lot of this information is based on their documents, and the key, of course, is that we can get this statistics without seeing any clinical protected data immediately on this cohort. All right, so we're done with the dashboard, showing you that example, and now I just want to show you briefly an additional way we leverage this data on the NLP team, where we focus on mining these concepts. Once our executive users have discussed it with our innovation partners and have identified important considerations, important clinical evidence that we want to capture. So this is very simple, but this is a very powerful tool for us, once again, in order to search truly all of our patient data. We're talking about millions of documents and all the associated data that came from databases in a single place in order to understand, in this case, what is the text around a term around a clinical text that we want to capture. So in this case, the term of interest for us is amplification, and we have a number of, we leverage Databricks widgets in this notebook that is connected to Elasticsearch. And again, immediately it can serve up, at scale, millions of examples of where this particular term is utilized. We have particular parameters that we specify for the number of engrams that we want to analyze, and the varying window for the snippet size around the term of interest, as well as particular terms to the left and the right. And so right away on the NLP team, if I'm interested in a new concept, I can go in here and get, at scale, search all our millions of documents, get whatever size of snippets that I want. I can limit my response from that client to, let's say, 20,000 examples of this particular term, and analyze the context within and understand what is actually happening in terms of language around this particular clinical consideration of interest that I may want to write an algorithm to capture. And again, the power here is building that initial index of connecting patient documents, patient text with structured data, and indexing all of it in Elasticsearch. And then when I connect to it from this notebook, I'm able to answer my questions immediately by searching all the clinical text. And so, in conclusion here, the big advantage of this approach, which is technically quite simple, but very powerful for having a comprehensive patient data view immediately. So as I just mentioned, we have a comprehensive patient data view, and our clinical notes are truly critical. They're very important, one of the most important data sources for understanding what's actually happening with the patient. And structured data often will miss out, is slow to change, will not include the latest clinical considerations. Our solution here is scalable because we leverage Elasticsearch, which solves the problem of querying a truly large number of text, of millions of documents, and serving you that result immediately, leveraging index-based search. And Databricks, for us, serves as a unified workbench that allows us to connect a variety of data sources to our text, millions of PDFs that would otherwise be locked somewhere in the cloud storage, and to all our databases in a single place. And we leverage Spark tables, and specifically Databricks Delta tables, to build in all this data and aggregate it in a nested structure per patient, and then stream it from Databricks into Elasticsearch. And importantly, Elasticsearch API and Databricks, it really helps us to build additional tools within Databricks that assist us with the NLP concept development and have insight into these documents. And lastly, the specific example that I showed you here is the executive dashboards are user-friendly. Allows us to really customize our aggregation analyses for anything that's important to an executive user to understand the statistics on all of these documents that we have and derive insights immediately. And so we can quickly search text and gain these quantitative insights immediately, actually without seeing any of the PHI data. And that is all. Thank you. If there's any questions, I'll take your questions.
Thank you. I appreciate your energy. You had some of the best energy of all the speakers I've listened to. So I got a few questions for you. It's going to be, hopefully you can answer most of them. Number one is, how did you get access to all this data? Number two is, you're being a business, like what do you see, how do you see yourself monetizing or your company monetizing these results in the future once you achieve your goal of figuring out what is the most effective treatment for cancer? And then can you share any initial positive results? Like how did you guys see any insights on, hey, this is really working in terms of cancer treatment yet? Mm-hmm. And what problems have you ran into in terms of actually seeing specifically actionable results? Yeah.
Yep, so there's a number of questions. I'll try to answer them in reverse in order. So first, the cancer treatment review, independent cancer treatment review, has been the core of OncoHealth business for maybe 15 years. So this company was started by a number of physicians that, oncology, they see a lot of death, and this particular business was kind of a number of physicians that have reviewed complex cases and made an independent recommendation. So really the goal to ensuring that patients are truly receiving the best treatment recommendations, and they have additional opinions, independent opinions in the process. And so for each particular consideration, remember 15 years ago when this company was started, they would again have faxed in perhaps hundreds of documents. A physician would sit down for this really important and often very valuable and expensive decision and would read through and highlight and identify the key considerations and would make an independent recommendation. And of course, this continued at scale where we have many, many clinicians that are hired and are doing this case review process for now hundreds of thousands of patients across the country. And so as our cloud client base grows, we have a lot of data that we have collected over the years as well as collecting now from these clients with whom we partner for case review. And so let's see, the next question.
How do you guys plan to monetize?
Yep, so in order to, our goal is not to sell data by the pound, right? So we're not to become just another Optum, et cetera, or not to compete with electronic health records to drive some simple information or just drive patient information, but truly provide insights in emerging clinical considerations. So again, an example would be an ISPOR conference just happened. We have 1,000 oncologists that were present for an important talk on a rare disease, on a rare oncology condition. And they're presenting definitive clinical evidence on a particular genetic consideration. And our goal is been to doing this continuously over the past 3 years and building a data set for capturing clinical information that is key to cancer treatment that is not available in EHR claims data and other structured data, and mining that from the documents where clinicians who just left this conference would then submit a treatment, and they would reference this particular clinical consideration within. And we can see this in real time. And our oncologists would tell us this and drive this process, saying, hey, this is a high-value clinical consideration that we need to capture, and because this will be really important for this important genetic therapy further treatment development. And oncologists would come back, they would tell us this, we would then go ahead and mine this particular concept, and we would see this immediately within our data. And then our executive staff would then reach out and partner as innovation partners with the drug developers in order to deliver these additional insights into how this particular clinical consideration is being used by clinicians in the field and how it's affecting the patient. And of course, it could be a clinical consideration that's important in understanding how physicians are applying this and leveraging this new test, new genetic marker, new treatment, et cetera, as well as how is the patient responding to this? What are some of the challenges? What are some of the symptoms, et cetera? And a specific example would be dealing with cancer spread, right? Cancer spread is typically a diagnosis of metastases is given, and when the patient is metastatic, it's really important clinical transition in the journey of that patient, which means the intent for treatment becomes, the hope for cure becomes a lot less, right? And it really changes everything about that. One of the most important transition in the cancer patient journey. And as you can imagine, cancer spread can be, there's a diagnosis for it, but it can be indicated by the physician in a variety of ways. And that particular condition can be expressed and noted in the patient notes, again, in a very detailed way and in a variety of ways. And so we build an entire concept, what we call a concept, around capturing information about cancer spread about a patient. And of course, it has to be done one diagnosis at a time because there's particular differences on the type of cancer that it is. And so first, we want to go ahead and capture all the text that has to do with metastases and work with our clinicians to identify the key different what does the text actually mean, right? Like, is a local spread to the lymph nodes? Is it spread for blood cancers, spread for something, solid tumors? All these things are very different. And we want to go ahead and develop these concepts, and we leverage, in this case, Elasticsearch with physicians to understand how exactly are doctors diagnosing this, what language are they using, what are the stages, because the first stage may be imaging, where the doctor just suspects it, they give it to another doctor who, again, has to deal with this, and when is the definitive diagnosis made in the pathology report, and et cetera. And so we need to go ahead and map this particular concept, extract it from the text, again, working together with doctors and clinicians, and then finally build machine learning models to understand the context around this text in order to be able to, for our case, about 98% confidence, say, is this a yes or a no? And again, this is not a definitive recommendation, but within our data set, now we can work with drug developers, et cetera, people who want to understand how metastases impacts the patient journey for a particular treatment or particular consideration. We have now mined this data from millions of records millions of free text documents and an applied variety of clinician insights and machine learning models to add insights to exactly how metastases is impacting the patient journey. And the ways to monetize this is to partner with have innovation partners with providers as well as some of the drug developers. That's a long answer. Sorry about that.
We might have time for another one or two questions.
Thank you. Here. Do you receive data from other countries as well, or other healthcare data providers? And are you interested in receiving data from other countries and other regions?
Right now, we only receive data from the United States, and we actually cover like 95% of Puerto Rico, which is very interesting, and processing data in Spanish and seeing some of the differences in physician preferences in Puerto Rico versus mainly the United States. As far as international, I really can't answer that for sure. Me on the NLP team, more data is always better. We welcome it for sure.
And the last question over there in the room.
Thank you so much for this extensive presentation. I know at the last part you covered that you want to contextualize the clinical case and then make a machine learning model. However, I want to ask, have you thought about making Elasticsearch itself doing sentence transformation and contextual embedding? Because you just mentioned if somebody is searching for bladder cancer, they will get all the clinical cases mentioning bladder cancer diagnosis, but personally, or I have known that bladder cancer is just one part of metastatized cancer. So maybe it started with lymph node cancers, or in spleen maybe. So, or the clinician will be searching for renal cancer, and he will get renal papers, but all the bladders will be missing. So how are you thinking about that? And have you thought about making the search itself intelligent enough to understand the context of the query?
As of right now, we are not leveraging these further built-in kind of transformations into segmenting our text within Elasticsearch in particular, but this becomes really important for us. We leverage Spark NLP for this. They're one of the John Snow Labs, one of the key vendors here and partners with Databricks, in order to separate, to have different transformations per document type, the kind of information we're dealing with, and segment things into sentence. And of course, as you can imagine, with the free text documents, it's a whole separate problem to identify the most relevant unit of text that captures the meaning around a concept like cancer spread. And then, of course, we leverage a variety of text embeddings. A lot of them are, again, through Spark NLP, we find that the most useful and easier to use, and transform that data and build models on top of it. That's a good suggestion.
Good. Dimitri, thank you very much for your presentation.